Today we are doing 9.3, multiplying polynomials. We're going to be multiplying. So y'all learned what a polynomial is and what it is not. Remember those rules, terms, etc. Learning how to find the degree. Yesterday you added and subtracted them. And I didn't care how you did it, but we talked about all you're really doing is combining like terms. Try to remember to do the best you can at descending order, but it's not detrimental if you don't. I'm not counting off of that. Again, I don't even think our Excel counts off. Today you're doing multiplying polynomials. Tomorrow you're going to be doing something similar. And then, another type of multiplying. And then we get into about 2 days of dividing polynomials. Now let me tell you, I hate the second part of the dividing of polynomials. It's like long division. It's tough. But as your upperclassmen here in the school tell you, you have to learn it. You will see it again and again and again. And I have divided the division of polynomials into 2 days for a reason. It's that ugly. So enjoy the multiplying while you're doing it. Okay, so the first thing, you're going to arrange both factors in descending order. Are you writing? Descending powers of the same variable. By the way, today, if you are like, I don't understand what I'm doing, or you're struggling, today I'm going to ask you to show me your notes. If you do not have exactly everything that I have written down, you will not get help. Do we understand each other? Again, like I said yesterday, 7th grade found that out today. They did perfect. But that's going to go for y'all too, so y'all better write it all down. Arrange both factors in descending powers of the same variable. And I'm going to show you what that means. Multiply each term by each term multiplicand. And I'm going to explain all that to you, so don't freak out.
Multiplicand?
Oh yeah, I'm going to show you. Just write this down. Be good children. You're going to combine like terms. And you're going to be using the distributive property. And I'll let you catch up. Keith, if you can't see in the back very well, you can move up, you know. Anyone else in the back row can't see. Okay, this isn't bad. I'm here to tell you it is not bad. Division's going to be fun. This is not bad. The wording sounds bad. Wait till I do some examples and it's going to click. When you're done writing, put your pencil down so that I know that you're done. If you can figure out, well, yeah, all this is important. Putting the factors in descending order, that's important. The powers, combining like terms, using these two you get, y'all gonna be fine there. This stuff is kind of weird, but not really. I only have 1 page of notes. We said that yesterday, but it was kind of crazy. But this is not bad.
Front and back.
All right, we good? All right. Let's go ahead and open up our books and start with some examples. Exactly. Y'all learn better by examples anyway. Page 382. 382. Let's look at number 11.
Okay.
All it says to do is multiply. So write down this problem. Negative 7k times 8k squared plus 9k plus 6. Now we're going to do distributive property. What?
That's right.
Okay. So we're going to take this negative 7k, we're multiplying it by everything inside the parentheses. Now, some of y'all yesterday, for I think the cumulative, not just you, a lot of y'all forgot how to multiply with variables and exponents. At least half this class. Y'all just forgot. So we got to remember how we do this. If the bases are the same and we're multiplying, what do we do to the exponents? Add them. So for example, are the bases the same here for this variable?
Yes.
They're both k's, correct?
Mm-hmm.
Right?
Mm-hmm.
So Sophia, what if I'm multiplying, what do I do to the exponents? You're so smart. All right, so Franz, negative 7k times positive 8k squared, what do you get?
56k cubed.
That's right, negative 56k cubed, or to the third power. Does everyone see where he got the little exponent 3? All right, very good. Negative 7k times 9k is what, Franz?
Negative 63k squared.
And then negative 7k times 6 is?
Negative 42k.
All right, now, arrange all the factors in descending, blah, blah, blah. These are descending. Yesterday, remember, I was trying to go the other direction. Today, I'm better. Here's your answer. Everything is perfect. Any questions? That is what we're doing today. Isn't that nice? Oh, yes.
How is it a polynomial? Or like the actual multiplication problem?
How is it a polynomial? Well, that's negative 7k is a monomial.
So that counts as 1, and then the other one's 1.
Yeah, and how many terms are in this?
3.
Yeah. Yes. Yes. Oh, I like what she said. Look at number 5. She said, do you take that negative 4b and do you multiply it by everything on top? Yes. Let's do that one real quick. Because that's a good question.
Just a little like something.
So it's 5. No, you're all writing this down.
Mm-hmm.
I will be checking if you ask for help if you have this written down. So you better do it. Everyone better write it. Okay, so this is a term. This is a term. Both of them together is a polynomial. Here's a term, one term. It's a monomial. Okay? So when you're multiplying, it looks like this. You're doing it just like you would any other multiplication. You're going to multiply it with the 10b and the 5a. So in this case, negative 4b times 5a is what new? There you go, negative 28b. And then negative 4b times 10b is what new? There you go. because we're multiplying, so we're adding the exponents. We pretend if there's no exponent there, Sophia, what do we pretend is there? Very good.
What about like ones like 8 or 9, like where there's 2 variables?
Okay, well let me get to, let's see, is it the next one? Let me get to the next one. It's going to be handled the exact same way. Okay? Does anyone have any questions over this?
No.
Okay. So let's look at 13. No, 13 is not done the same way. Let's just do it anyway.
Just do 9.
13a squared times 4a to the 4th power plus 5a minus 18. Guys, I want to tell you something. In your years of high school, any test or something, you're not going to see these problems really written out like 4 through 9, which is why I start on this section. They just don't write them that way. This is how they write them. I don't even know if IXL would even do it the other way. I'm not sure. I haven't looked at it. This is what you're going to see. Again, we're going to do distributive property. I'm going to start calling on random people. So be ready. Keith, what would be my first one?
Multiply the squared times squared to the
Uh-huh.
you get 12a
12a to what?
this is
Yeah, perfect. Now, if you do not understand how he got that, you need to raise your hand. We're adding the exponents. Ariel, what about the next one?
It would be 3a squared times 5a, which would equal 15a cubed.
Very good. And Miranda,
-64,
close.
-54, a squared.
Perfect. And it's in descending order. A6, A3, and A2. And we're done.
Oh, you did something.
Any questions so far?
No, ma'am.
Does everyone have this down? All right, let's look at 15. That's going to answer some of those questions that you had on those weird ones. All right, was it number 9 you said? Yeah. Look at 15. It's pretty much the same thing. Now, this paid very close attention because what you're going to do is multiply, I'm going to cover that up right there. You're going to multiply that y by everything over here. Then you're going to go back and multiply that -4 with each of these things. So watch what I do. I'm going to start with the y. I'm going to multiply the y with that one and the -3. Y'all see that? So let's start there. What is y times y? Raise your hand. Chat. Y squared. What is y times -3, Sophia? Very good. Now I'm going to come back. Watch what I do with my arrows. And I'm going to multiply the -4 with the y and the -4 with the -3. Let's see, new. What is -4 times y? Very good. Morgan, what is -4 times -3?
12.
Are there any terms that I can combine, Franz?
The -3y and the -4y.
That's right. Look at these guys. See that? I can combine those. And what would that be, Franz?
-7
That's right. It'd just be -7y.
squared.
No,
Oh, wait.
because we're adding and subtracting. All right. And there's your answer. Remember, this was a mistake yesterday. And listen to my voice, when you are adding and subtracting, the variable and whatever exponent's got stays the same. You only make changes when you're multiplying, like y times y is y squared. But when you're adding and subtracting, you don't change that. Does everyone see that? Okay, any questions? Does that help, Morgan? All right, let's look at 17. I got 2 more and then I'm setting you free. C minus 3 times C plus 8. So I'm going to, remember, we're going to start with our first, term, constant or variable, and we're going to multiply it with everything over here. Valeria, what is C times C? Perfect. What is C times 8, Ariel?
It would be 24. Wait. It would be 8C.
It would be 8C. Very good. That's okay. That's why I draw arrows. Now, Morgan, what's negative 3 times C?
Negative 3C.
And then Chap, what's negative 3 times positive 8?
Negative 24.
And Miranda, are there any terms that I can combine?
AC negative 3C.
Perfect. And what do you get, Miranda?
5C.
Yep. Any questions? All right, I got one more for you. Y'all better write this down. Same thing goes if you have a trinomial, like 3 terms, and the multiplying is on the right side this time. Oh my. This just looks ugly.
Why can't you not just move the
Can you
left side?
switch it to make it easier?
If you want, but you could also just multiply this first one by each of these things. Let's start with that.
Cool.
Oops, my arrow. All right, so, and you can go either way. Are y'all looking? What's x times, let's say 4x squared? What would that be? Raise your hand. Franz?
4x cubed.
4x cubed. What is x times negative 3x, Sophia?
Negative 3x squared.
What is x times negative 6, Ariel?
Negative 6x.
Perfect. Now we're going to come back and do the same thing with the 2. Two times 4x squared is what, Keith?
8x squared.
Perfect. Let's see. Miranda, 2 times negative 3x. And then Chap, 2 times negative 6.
Negative 12.
Now we combine our like terms. Let's see, Morgan, what are my like terms?
Negative 3x squared. 8x squared. Negative 6x. And negative 6x. And
Okay, so I have 4x cubed. And let's see, Chap, what's negative 3x squared plus 8x squared?
Positive 5x.
I'm going to cross those out. And I'm crossing that out because I've already written it. Let's see, Franz, what's negative 6x and negative 6x?
negative 12x.
Very good. And then the last thing is negative 12. Is this in descending order?
Yes.
There you go. Any questions? None? Y'all ready to be set free?
Yep. Sure.
All right. So let's see here. Oh, this should be fun. Okay. You are doing page 382, 384, numbers 10 through 24 even, and 50 through 56 even. Y'all need to start reviewing big time. Honors 20 through 34 even, and 50 through 56 even. This is due Thursday. I forgot today was even Friday. Wednesday. See? I did not know what today was. Okay, your IXL is due Monday, and you have a quiz on Monday. There you go. You may get started.